We're exploring how eggs might evolve over the next 200 years or 23rd century, from traditional farms to futuristic space labs. What if I told you the simple egg, the breakfast staple we all know, might be grown in a lab, printed in your kitchen, or even harvested in a lunar farm by the year 2300? In the next few minutes, we're cracking open the journey of eggs from ancient farms to future tech. And trust me, this is no ordinary food story. Let's start where we are now. In 2025, the humble egg is one of the most consumed foods in the world. We use it for breakfast, baking, and even beauty treatments. But most of us don't think twice about how it gets to our plate. In the US, eggs are washed and sanitized before reaching the store. That process strips away the egg's natural protective coating, called the bloom, so they're often sprayed with mineral oil to keep them fresh. In Europe, it's a different story. Eggs aren't washed or coated. They keep the natural bloom and are stored at room temperature. This is possible thanks to strict regulations and vaccinations to prevent salmonella from the inside out. Now, fast forward 75 years to the year 2101, the dawn of the 22nd century. Climate change, population growth, and food security concerns are reshaping how we produce and preserve food. Eggs are no exception. So what changes? 1. Edible nano-coatings. Engineers and food scientists develop ultra-thin, edible films made of chitosan, seaweed, or protein-based nanomaterials. These coatings self-repair small cracks, block bacteria better than mineral oil, and are completely biodegradable. Eggs stay fresh for months without refrigeration. 2. Smart packaging. Cartons now include biosensors. These sensors detect spoilage gases, track temperature history, connect to your smartphone. Your phone can tell you if an egg is fresh without you cracking it open. 3. Synthetic shells. In some areas, hens are replaced by bioengineered layers, hens genetically designed to lay eggs with synthetic hybrid shells that are stronger, thinner, and more sustainable. These shells could even include embedded freshness indicators or color-changing surfaces. By the end of the 22nd century, we're already asking a big question: do we still need real eggs at all? Now, we step into the 23rd century. The year is 2201 and beyond. The world, and even space, has become our kitchen. The way we define an egg is changing completely. 1. Lab-grown eggs. By 2210, the first fully lab-grown eggs hit the mainstream. They're not plant-based substitutes, they're real eggs, built from the bottom up. Proteins are grown in bioreactors. Yolk and white are structured using 3D bioprinting. Nutrition, taste, and texture are customized per person. There are no chickens involved. No waste. No disease risk. 2. Egg printers in every kitchen. Eggs are no longer bought, they're printed. You feed your nutrient printer a capsule filled with amino acids, minerals, and fats. The printer assembles the egg cell by cell. Craving an egg? Say it, and it's there in under a minute. 3. Space eggs. As humans expand to colonies on the Moon, Mars, and space stations, conventional farming isn't viable. But eggs are still valuable nutrition sources. Solutions? Microgravity poultry farming. Enclosed egg synthesis labs that recreate Earth-like growth environments. Closed-loop nutrition systems where eggs are built into the life support ecosystem. Eggs become part of the space race and a symbol of survival. Now let's ask, is an egg still an egg in the 23rd century? It might not have a shell. It might be grown from algae proteins. It might never see a chicken or a farm. But if it provides the same taste, the same nutrition, the same cooking potential, does it matter? Culturally, we'll likely see a divide. Some may hold onto heritage eggs, real eggs from heritage chickens on earthbound farms, as rare luxury items, even status symbols. Meanwhile, others will embrace the egg as a customized nutrition unit, a product of human ingenuity. Eggs will become like coffee or music formats, different generations, different versions, same core idea. With all this change, we must ask, what are the consequences? 1. Ethics. No chickens equals no cruelty. Fully controlled production equals no salmonella or avian flu outbreaks. But what about genetically altered animals or synthetic embryos? 2. Environment. Lab-grown eggs could cut emissions by 90%. Eliminate the need for grain-based chicken feed. Reduce waste from packaging and spoilage. Yet they require energy, infrastructure, and trust. 3. Social impact. Will synthetic eggs widen the gap between rich and poor? Will traditional farmers survive? Will we even know what natural means anymore? The future of eggs isn't just about science, it's about society. From clay coops to climate-controlled labs. From farm fresh to space-grown. The egg, so simple, so familiar, might just be one of the most radically reimagined foods of the future. In the 23rd century, we won't just ask, is it fresh? We'll ask, was it printed? Engineered? Personalized? Do you want yours with extra protein or extra ethics? Because in the future, even your breakfast comes with options. High-protein eggs engineered for your morning workout. Could eggs become personalized nutrition packs, tailored to your DNA or daily goals? Yolk colors you can customize, turmeric gold, spirulina green, or vitamin-enriched red. Will chefs in 2300 treat yolk like an art form or a health supplement? Flavored shells that dissolve into your dish, truffle, smoked paprika, or even coffee-infused. Could flavor-enhanced shells be the new seasoning drawer? Eggs that glow faintly in low light so astronauts can cook in space. Sound wild? NASA's already exploring luminescent materials. This might be closer than we think. Digital recipes that whisper ideal cooking methods via smart kitchen assistants. Imagine cracking an egg, and your kitchen guides your next move in real time. Time-released eggs that crack themselves in boiling water for perfectly poached results. Could we design eggs with built-in cooking tech? Self-poaching may sound far-fetched, but smart ingredients are on the rise. Ethically coded QR tags scan and see the full sustainability score, down to the molecule. What if you could instantly know how green your breakfast really is? Would it change your choices? Eggs engineered to reduce food waste, perfect size, no cracks, extended shelf life. Could smart design eliminate the billions of eggs wasted every year? Portable egg pods for travelers, hydrated with water to become a full egg in minutes. Will astronauts, soldiers, or campers carry eggs in powdered or encapsulated form? Eggs with built-in nutrient sensors that adjust contents based on your diet plan. What if your egg could detect your deficiencies and fix them before you even eat? Holographic egg labels with farm-to-table histories and freshness countdowns. Could transparency redefine trust in food? And would it reshape how we shop? Designer eggs for pets, nutritionally optimized for dogs, cats, or even livestock, is the pet food of the future also 3D printed, egg-based. Cultural style eggs preloaded with flavor profiles, Japanese tamago, Spanish tortilla, Indian masala. Will global cuisine be encoded directly into food itself? Eggs as digital assets. Custom egg recipes stored on-chain, traded as NFTs or used in virtual cooking games. Could your breakfast someday exist in both your kitchen and the metaverse? And maybe the biggest question of all, will we even need to eat eggs, or will we just simulate their flavor, nutrition, and texture through neural stimulation or food patches? One thing's for sure, whether we grow them in labs, print them on demand, or farm them on Mars, eggs in the next 200 years won't just be food, they'll be tech, art, and data. If this video cracked your curiosity, don't forget to like, subscribe, and hit the bell icon for more stories about the future of food and tech. Drop a comment below. Would you eat a lab-grown egg from a 3D printer? Or are you sticking with the classics? Until next time, stay curious, stay hungry,